Hello everyone. Thank you for checking out Graph Toolkit, Unity's new solution for building custom editor graph tooling. My name is Anita. I'm the UX designer for Graphs at Unity, and today I will be taking you through the core features available in our experimental package, and hopefully spark some ideas and inspiration for what kind of graph tools you can create for your project. Throughout, I will be demonstrating the end user experience that comes out of the box when you make a graph using Graph Toolkit, as well as the UI, possible user customizations, and the intended design and purpose for each of the available features. Please note that this is not a technical walkthrough or tutorial. If you are looking for guides on implementation and setup, you can refer to our other available documentation and resources. Thanks for giving Graph Toolkit a try. Now, let's get into it. First up on the agenda, I will be showcasing some of the editor interfaces you will have in any graph tools created using Graph Toolkit. When your graph first opens up, this is going to be pretty standard for what you can expect to see. What we are using is the overlay system, which you can find in the main scene as well. The benefits of the overlay system is that it gives a lot of flexibility to the end user. As you can see, you can essentially move your toolbar around however you like. A tip is that if you press the tilde key, it will open the overlay menu, which will allow you to easily toggle on and off anything you can see here. You can also save presets, which is pretty useful. Here in the upper right corner, we also have toggles that allow you to quickly turn on and off the most important auxiliary panels, which I will go into next. There's a lot going on in the Blackboard, so I will have a section dedicated to it later in the video. But essentially, the Blackboard is where users go to create and manage variables. On the right here, we have the Graph Inspector, which is a local inspector that exists only within your graph window. The Graph Inspector is contextual to what you have selected. So right now, it's only showing things for my variable. If I create a node, it will show information regarding the node. If I have nothing selected, it will just show information regarding the graph asset or the graph model. The Graph Inspector does support multi-edit. As you can see here, if I have two nodes selected, it will show you everything it has in common, in which case you can multi-edit both of them at the same time. The node inspector also comes with collapsible sections that you can customize. Moving on to the minimap, our offering is pretty basic and standard at the moment. It tells you your zoom level and gives you a preview of what is on your graph. Currently, you cannot navigate by dragging around in the minimap. However, you are able to select nodes within the minimap, like so, and it will navigate you to the ones you have selected. Speaking of navigation, we also have some pretty standard canvas manipulations that come out of the box. You can zoom in and out using the scroll wheel, of course. You can also pan by holding down the middle mouse button, or alternatively by pressing Alt and holding down the left mouse button. We also have an auto pan feature as well. So as your mouse gets closer to the edge of the screen, the canvas will automatically pan. Two final features. First one being that we do have a variety of shortcuts, which you can find and modify in the Shortcut Manager. We do plan to add more to it in the future, but these are the ones we currently have, which you can see as well as edit in the Shortcut Manager if you like. Last but not least, just a small thing, but we do also support light theme. And that's it for general graph interfaces. Next up, let's talk about nodes. I will go over nodes, the different sections of a node, as well as all the features we have that you can utilize to customize your nodes. In the API for the experimental, you will only need to worry about the options and the ports. However, I would like to quickly go over the UI layout just for your understanding on the anatomy of a node. At the very top is the header. On the left, you have the icon, the node title label, and the subtitle. On the right, you have the node toolbar, which for now shows up by default with only the collapse option. In the future, as we expand the API, you will be able to customize and add additional buttons here. In the middle section between the header and the body, we have the node options, which is designed for you to add options that will affect the rest of your node. In the body of the node, we have what we call ports, which are these horizontal rows going from left to right. We have the port container, icon, label, and input fields. And the same thing on the output side as well. In the editor, I just want to quickly showcase how one would go about creating a node. You can do so by either right-clicking anywhere on the canvas and selecting Create Node from the right-click menu. Alternatively, you can press space on your keyboard, which will also bring up the item library. Here we have some examples of the node options, which are settings that impact the rest of the node. And that's it for nodes. Moving on, let's talk about ports and wires. Graph Toolkit comes with a set of common data type icons and colors. You can use these to be consistent with other Unity graph tooling or create your own custom ones. Moving into the editor, let's take a look at these ports in action. First off, ports do have a tooltip that appears on hover. By default, it shows the label of the port as well as the data type. In addition, we have the concept of plugged ports, where fields disappear upon plugging a wire in. If all of the ports are plugged in for a given node, then the node resizes to free up more space in the graph. This feature also helps drastically the performance of your graph, especially when you have a large number of nodes on the canvas. Moving on, let's talk about wires. Wires are the lines that you can drag out of ports and use to connect nodes to one another. They are pretty simple and self-explanatory, but I just want to quickly go over some of the cooler features Graph Toolkit supports out of the box. Firstly, our ports have a large hitbox as showcased here with this visual, so that the users are able to connect wires even when the graph is greatly zoomed out. Secondly, we have some accelerators built in for creating nodes from wires. You can drag out of a port and let go on a canvas for the item library to pop up. If you select a node here with a compatible input port data type, then it will be automatically connected. You can also right-click an existing wire to insert a node in between the wires. Okay, so moving on, let's talk about the Blackboard and variables. I will go over the UI we have for different types of variables, as well as the functionalities we offer in the Blackboard. To begin, I want to review the different variable types and the visuals we have out of the box for them. First off is the default classic variable. You have your icon, label, and port connector. Next, we have the input and output variables. These are indicated by a stroke on either side of the variable capsule, depending on which direction the data is coming in from. If your tool supports subgraphs, then these are what become the input and output ports of your graph as a subgraph node. Here are all the variable types we just discussed, shown as seen in the editor. Now, if I drag another graph with a similar Blackboard setup into this graph as a subgraph node, you can see what I mean with the input and output ports in action. Now let's dive into the Blackboard a little bit more. There are a couple of different ways to create a variable in the Blackboard. We have a split add button. If you select the dropdown, you will pop up the item library where you can choose the specific data type you are looking for. You can also pop up the item library by pressing space while hovering over the Blackboard. Clicking the add button will add a variable instantly. The default we currently have set for this is a float. However, once you select another data type via the dropdown from the item library, then the add button will create variables of that last selected type. From the canvas, you can create a variable directly from the item library. Alternatively, you can drag out of a port and create a variable of that data type. Once you have created your variable, you can go to the Graph Inspector to edit the settings. The Graph Inspector can show properties such as default values, tooltips, as well as any additional settings required for your tool. As mentioned a while back in the video, the inspector does also support multi-edit of values. Going back to the Blackboard, you have a couple of ways to reorganize your variables. These are easily reorderable. The order in the Blackboard also reflects the order in which your variables appear on a subgraph node or inspector. You can also organize your variables by creating groups. To do so, you can create it using the item library or right-click anywhere on an existing variable. You can easily add or remove variables from groups. Groups can be duplicated. nested within each other, as well as collapsed. Last thing on the Blackboard before I move on to variables in the canvas. You may be wondering what these little arrows are beside the variables. If you select it, it will open what we call the quick settings. As a tool developer, you can pick which properties are the most high traffic for your users and add them here so the users can edit these properties directly in the Blackboard without having to travel across the graph to edit them in the inspector. So, in order to use a variable, there are a couple ways. You can drag it from the Blackboard directly into the canvas to create a capsule. You can also drag it directly onto a port with a matching data type as well. Since you can have multiple instances of a variable on a canvas at any given time, the orange highlight is there to show you the ones related to the one you have selected. This highlight can also be seen in the minimap. Variables can also be converted into constants and vice versa. Constants can be created directly in the graph canvas via the item library as well. Constants are a one-off instance of a value. Once your variable is a constant, converting it back to a variable will create a new one. Lastly, I just want to demonstrate that you can also copy-paste a variable between compatible graph assets. Here in the second graph, I have this vector3, which I will copy and then paste here. As you can see, the name and all the properties have been carried over. And that's it for variables. Next up, let's chat about the item library panel. The item library, or what some might refer to as the searcher, can be activated in both the canvas for nodes as well as in the Blackboard for variables. It is meant to be used to create things into the graph. In terms of basics, you can resize the whole window, resize individual sections. We also save the close and open status of the categories between each time the user opens it. The first feature I want to showcase is the nifty Node Preview panel, which you can toggle on and off via the eye in the top right corner. The Preview panel will show you a preview of the node you are about to create. Next up, we have a favoriting feature which you can activate by hovering over any line item and selecting the star on the right-hand side. Favorited items will show up at the top of the item library for quick access. In terms of searching, we do have a smart or fuzzy search built in. Feel free to play around with it. But as an example, the user will be able to type in something like LOE, and it will return less or equal. Lastly, we do have a more hidden feature that only activates when you drag a wire out of an existing node. If you select a node to automatically connect with this port, and that node has multiple compatible input ports with the data type of the wire, the item library will allow you to pick which port to connect it to. Alternatively, you can also just double-click the name of the node for it to connect to the first one. Moving on, I will discuss a special type of nodes called the context nodes. What they are, what they can be used for, what are these things called blocks within them, and what functionality comes built in. Firstly, I wanted to go over the concept of a context node. To explain what they are, let me first show some familiar visuals of existing graph tools. Previously in Unity, if we wanted a way to stack a bunch of related functionality together in a graph, tools would make their own custom implementation on this. In Graph Toolkit, we aimed to unify the visual and create something that is more than just a visual container, but also scalable and functional. We call these the context nodes. We call them contexts because they have a context for the content that exists within them. Similarly to stacks, contexts are used to group segments of related logic. The terminology we use for what exists within a context is a block. It is important to note that blocks are not nodes. You will not be able to drag a node into a context to convert it into a block or vice versa. This is already the standard behavior in existing Unity graph tools as well. Contexts are meant to provide the users with a guided experience by limiting which blocks can be used within each context. Lastly, a cool thing about contexts is they come with settings at the top that will apply and impact all the blocks within it. All right, so let's move into the editor to see some of this in action. On the very left here, we have a context in the most simplest form. With just blocks, no settings, you can add blocks to a context by clicking this button below. Next to it, we have one that is a bit more complex. It comes with settings on the top, and the blocks contain both inputs and outputs. As you can see, since these are the same type of contexts, the blocks can be freely moved in between them. However, over here, we have context B, which is different and does not support the blocks that are typed context A. So that's it for contexts and blocks. Next up, let's talk about the nesting options you can have in your graph tools, aka subgraphs. Subgraphs are a great way for your users to create reusable functionality, and they are also great for organizing and cleaning up a large graph. In Graph Toolkit, we differentiate subgraphs based on whether it lives locally within another pre-existing graph or exists as a standalone file/asset. In other words, there are local subgraphs, and then there are asset subgraphs. Whether a graph is nestable is something that can be set through a method in the graph model. With asset subgraphs, if you make changes within the subgraph and save it to the same asset, the change will ripple out to all existing instances of the subgraph node. So here I have duplicated a couple of instances of the subgraph node. If I go ahead and add another input, save, you will see that change has propagated to all the subgraph nodes. With local subgraphs, on the other hand, each one is unique. If you duplicate it, you are not making instances. You are creating an entirely new subgraph. If you make changes in one, it will not propagate to the other local subgraph. For those of you familiar with the prefab workflow, you can consider local subgraphs as a default game object and asset subgraphs as a prefab asset. Similar to how you can create a prefab from a game object, create instances of the same prefab, then unpack a specific instance back into a game object. A similar workflow exists for you to convert local subgraphs to asset subgraphs and vice versa, but more on that later. Let's start with how you can go about creating a local subgraph. A local subgraph can be created from selecting a couple of nodes, right-clicking, and selecting the option from the menu. Alternatively, if you have a group of nodes in a placemat, you can also right-click a placemat to turn all of its contents into a subgraph. In doing so, your new subgraph will automatically have the name of your placemat. Note that any incoming wires will be converted into input variables, any outgoing wires will be converted into output variables, and any local variables that were within the selection gets duplicated in the Blackboard of the subgraph as well. Now let's inspect the subgraph node that was just created. You'll notice that subgraph nodes have a different shape than regular nodes. This is so the user can easily identify them from built-in nodes at a glance. You can also rename both the title and the subtitle from the local inspector. Comparing the local subgraph node next to the asset subgraph node, you'll notice some small details. Firstly, for asset graphs, the icon on the subgraph node will match the icon of your graph assets. Secondly, in the inspector, your asset subgraph will have a reference to the asset in the project, so you can easily find where the file is located. In terms of navigating in and out of a subgraph, you can do so by either double-clicking on the header or clicking the enter icon that appears in the node title toolbar on hover. To exit out of a subgraph, you can go to the breadcrumb in the window toolbar to return to the previous level. Now, let's say you pack some nodes into a subgraph and you regretted the decision. You can easily explode all the nodes back out by right-clicking a subgraph node and selecting Expand Subgraph. When expanding a subgraph, we automatically put it in a placemat for you, with the subgraph title as the placemat title. This way, you can easily repack it back into a subgraph via the placemat to subgraph creation workflow. In the cases where you had your nodes tightly placed around the subgraph node, this allows you to easily move all the nodes within the subgraph out of the way. Moving on to the conversion options. Let's start with local subgraphs. Local subgraphs are a great first step for organizing the graph as your user builds it out. Then, as the user continues building their graph, they might realize they want to make the functionality reusable and global across multiple graphs. To do so, they can convert by simply right-clicking and selecting Convert to Asset. By doing so, this will open a dialog that prompts them to save it in an asset. Once you have an asset graph, you can reuse this as a subgraph node across all your graph files. You can drag these subgraph assets directly from the project folder into any graphs, and they will appear in the item library as well when you search for nodes. If you want to specify the path of how the subgraph shows up in the item library, simply go into the asset subgraph, open the graph inspector, open advanced settings under the graph inspector, and change the node path. Here, you can also make the subgraph never appear in the item library if you like, and also add descriptions that will show up in the item library if you want to add any notes about what the subgraph is doing. The conversion from asset subgraphs back to the local subgraph is also done through the right-click menu. Simply select Unpack to Local Subgraph. This is essentially the unpack prefab functionality in the hierarchy. It does not delete the asset or impact any other instances. It just creates a local copy of your asset subgraph. All right, moving on to the second last section, I will go over some of the UI we support in Graph Toolkit for showing your users that there are errors or warnings in a graph. To begin, I wanted to show the error markers. Error markers are these little things that can be shown beside the nodes or ports to let the user know that there is an issue. Hovering over the marker will show you a tooltip on what the error is, and clicking one will open the console. In the case where you have multiple errors, like in the example of a subgraph with multiple problems within it, the marker will have a number indicator on it, and clicking it will show you all the errors within that graph. Next up, I wanted to go over some visuals we have for missing elements. First up is if you have a port that is already connected, and either something changed to the node definition or a subgraph where that port no longer exists. In such a scenario, we preserve the port for the user in case they want to drag the wire elsewhere, and the missing port will then disappear afterwards. On a bigger scale, if you had an existing node or subgraph asset that was completely erased, then we also have a visual. You can see that the node has changed and the icon has been replaced with an error icon. Now, if I undo that in the Windows Explorer, we do also support restoration of the visuals. And that's all for errors. At this point, I have shown you everything you need to create your graph tool. In this final section, I will go over quality of life features that come out of the box with Graph Toolkit, such as portals, placemats, sticky notes, and much more. First up, we have the portals. Let's imagine that you have a large graph, and there's a scenario where a wire needs to cut through a group of nodes in order to connect to another group of logics elsewhere in the graph. So you have this ugly line that is cutting through beautifully placed nodes. In such a scenario in graphs using Graph Toolkit, you can simply right-click on the wire and create what we call portals. You can see that the wire has been split into two portal capsules. From here, you can always revert it by right-clicking a portal and selecting Revert to Wire. Another useful case for these is if you have a single output that is used as an input in various locations scattered throughout the graph. In this example, instead of having 3 long wires like so, you can select the wires and convert it all to portals. You can see which portals are related by the orange highlight when you have one selected. If you realize that this output needs to be used in more than just these 3 locations, you can duplicate the output portals, or right-click the input and select Create Opposite Portal to create more. To revert everything back to a wire, simply right-click any portal and select Revert All to Wires. Moving on, let's quickly talk about a very simple feature, the sticky notes. These are very self-explanatory. You can right-click anywhere in the canvas to create one, then edit the title and content. You can resize them from the borders. You can also right-click and change the font size, as well as pick from a list of predetermined themes to change its colors. Next up, we have placemats. Placemats are a visual container for nodes and other elements in the graph. Note that these only exist as a visual border behind the graph elements. They are not groups in the sense that they do not have ownership of the items within them, and do not apply changes to the items within them in any way. To create a placemat, you can create an empty one from right-clicking the canvas at any time. You can also select a group of existing nodes, and the placemat you create will automatically fit the selection. If you resize the placemat and want it to fit to content again, you can right-click and select the Smart Resize option. To move your placemat, you need to select it at a header. This way, the user can still make selections within the placemat. When you have a placemat selected, you can open up the inspector for a couple of customization options. You can choose the font size, the title alignment, as well as the color of the placemat. You can also leave comments to remind yourself what is within this placemat. However, unfortunately, at this time, this is only viewable in the Graph Inspector. If you duplicate a placemat, all the contents get copied. While you are resizing, if the placemat is about to absorb any nodes in the way, it will be indicated with an orange highlight. Placemats can be nested within one another. Lastly, placemats do support Z-order. For example, if I drag this placemat down to include these two nodes, you'll notice that these nodes are not being included in the selection. This is because placemats have a Z-order within themselves. As you can see, the power calculation placemat is currently above the clamp calculation placemat. To change it, just right-click the placemat on the bottom and select Bring to Front. Now, these nodes will move with whichever placemat is on top. Moving on, another quick feature to go over, which is our level of detail system. We currently have a system in place in order for nodes and graph elements to still be readable from afar. The most notable difference will be at roughly the 20% zoom level, where the ports disappear and only the name of the node remains. From our user testing, the ports were generally unusable from this point and beyond, and removing them gave a great boost in performance for larger graphs. Next up, let's talk about the placement options we offer in Graph Toolkit. We have snapping, alignment, and distribution options. Currently, the snapping options are a bit hidden as you need to go into the preferences, then the Graph tab to toggle them on and off. We intend to move these to an overlay toolbar eventually. For now, let's turn all of them off and look through each one individually. Element snapping is pretty straightforward. Each element will snap to the edge of another. Connected port snapping is my personal favorite. This allows the user to snap the ports to each other and therefore straighten out the wires. Grid snapping is also extremely straightforward. Turning this on will allow your nodes to snap to the grids underneath them in the canvas. The last option is equal space snapping, which allows you to equally space out the nodes between each other both horizontally and vertically. In terms of other placement options, we have the standard alignment and distribution options, which you can access through the right-click menu when you have a selection of nodes. These are pretty standard to the expected behavior you've seen in other softwares, so I won't go over each of them. Finally, I just wanted to quickly go over the different selections we support out of the box, since there is a very hidden but useful feature. The most basic one is the rectangular selection. We also support multi-select from holding down Control and clicking on the ones you want. We also support freeform select and deletion, which are hidden for now behind hotkeys. You can hold down Shift while clicking and holding in an empty canvas to bring up the freeform selection. This will allow you to draw a line that will select everything it touches. Note that this is not a lasso tool, so drawing a circle will not work. If you hold down Alt on top of holding down Shift, the line will turn red and become a freeform deletion tool. This time, anything the line touches will get deleted once you release your mouse. And that's it for the overview of features available in Graph Toolkit in our Unity 6 experimental package release. Thanks again for your interest in Graph Toolkit. On behalf of the entire team, we look forward to seeing what you create.